And welcome, my dear students and my dear viewers, to another yet video on my channel, Mathematics Made Easy. Today's video is especially for my grade 9 students, and this is on Module 9, Lesson 8, System of Equations in 3 Variables. So today's video is going to be part 1, just a brief introduction, where you are going to see the graphical representation of system of linear equations in 3 variables. So you're going to look into the graphs, how the three system of linear equation in 3 variables looks like. And without wasting any time now, let's dive into the video. We solve a system of 3 linear equations in 3 unknown variables. There are 3 kind of cases or 3 types of solutions that are possible. The first case is when you have a unique or one solution. Next, when you have infinite solution, and lastly, when you have no solution. In today's session, we'll look into all these 3 cases one by one and look at the graphs and how does the graphical representation of each type of solution, where you have 3 system of equation in 3 variables x, y, and z looks like. So let's get started. Case where you have one or a unique solution. As you can see, there are 3 planes. So when we talk about system of linear equations in 3 variables, we are having the graph as a plane. So the first plane is represented by blue, the next one by orange, and the third one by green. So in this case, where the system of equations have one solution or unique solution, as you can see, they are meeting at just one point. I'm highlighting with a black dot here the point is represented by x, y, and z. Now this x, y, and z is a specific point and it has a special name also. The name of this point is ordered triple. Now I'm sure you're able to understand why it's called triple, because it has 3 coordinates x, y, and z. Generally, these are the 3 variables which you need to find when you get a question on this lesson. And they are ordered in the sense that they are arranged in this particular specific order. You cannot change x, y, and z. You cannot interchange or mix or match. So you have to follow this same order. That first coordinate would be the first coordinate would represent your x value, second coordinate would represent your y value, and third coordinate would represent your z value. So therefore it is a specific unique point, and this is how the graphical representation looks like. The next case is the second case, where you have infinitely many solutions, and there can be 2 ways in which the graphical representation can be done. The first case here in the infinite many solution is when the 3 planes, as you can see, the blue, green, and the orange meet in a specific line. So this black line, the vertical line that you can see, so all the points that are lying on this line will be the solution. So there are so many points. Therefore, it is the case of infinitely many solution. So that's the first one, when the planes intersect in a line. So all the points which are lying on this line will be a solution of the system. The second case which is possible is that every point on the line which represents the solution of the system, we already discussed, if each of the 3 equations, they represent the same plane, means they are coincident. All the 3 planes, orange, blue, and green here, are the same. So every equation is equivalent and every coordinate in the plane represents the same solution. So in that case, all the points lying in one plane will satisfy all the points lying in the next plane and the third plane. So these are like actually 3 planes, but because they are equivalent equations, so these are 3 coincident planes. Again, they will have infinitely many solutions, as all the points which lie on one plane will be solution of the second and will be the solution of the point. All 3 planes are equal and every equation is equivalent in this case. Which is possible is no solution, where either the 3 planes don't have anything in common. So as you can see, the first part, these are 3 parallel planes. So they don't have any intersection point and hence no solution. Or it can be the second case, that the two planes are parallel and they're intersected by the third plane. But here we are looking at common solutions, means the solutions which are satisfying all three planes. So again, even if two planes are parallel, you are not having any solution which is common in all three. So it is a no solution again. The third case which can be possible for the graphical representation in case of no solution is where the three planes, they do intersect, but there are no points in common that are in all three planes. So as you can see, this line shows the points which are in green and blue. This line are common in blue and orange, and this line is common in orange and green. But in totality, if we look at the common solution for all three planes, again for this case also we don't have any common solution. Hence, these are the three types of ways in which you can have the graphical representation of no solution. Video for today, a short video showing the graphical representation of the system of linear equation in three variable. Stay glued to my channel for the next video, in which we are going to be solving questions on each of the three cases that we studied today. That is the no solution, the unique solution, or the infinite solution. So if you like this video, give it a big thumbs up. If you have any questions, comment. And if you like the videos that I put on my channel, don't forget to subscribe to my channel. Until then, this is Ms. Ruchika signing off from today's session. Bye students.